online.
What you send it?
No, I'm sending it.
Send body to.
Feel it. One person is one.
Okay. We are going to start soon. Chemical bonding. Chemical bonding. Okay. We are starting now. This is the topic we want to treat today. Chemical bonding. Chemical bonding. I want you to take away what you've been taught in chemical bonding in your school, the way you are taught, and listen to this new way it should be taught. Okay, let's start. Are we set? Are you set? Okay, welcome to this new week where we are starting with chemistry. We are looking at chemical bonding. What is a chemical bond? What is a chemical bond? You have to know the meaning of chemical bond, because without chemical bond, there won't be what? Chemistry. Chemical bond is one of the basic things you have to know in chemistry. All molecules, all compounds undergo what? Chemical bond, or exhibit what? Chemical bond. I repeat myself. All molecules, all compounds exhibit what? Chemical bond. And what is a chemical bond? What is a chemical bond? Just take note. This is the force of attraction. This is the force of attraction. This is the force of attraction that holds atoms or ions together to form molecules or compounds. Take note of these. Molecules or compounds. Write it down. Whenever you hear the word chemical combination, in another word, they can call it chemical word combination. Can you hear? They can call it what? Chemical word combination or chemical bonding. What is chemical bond? I said chemical bond is a force of attraction. Take note of this. It's a force of attraction. Chemical bond is a force of attraction. It's a force of attraction that holds atoms or ions together is a force. What kind of force? Force of attraction. It holds ions together to form what? Molecules or compound. That is what chemical bond. And another thing that we have, it came out Jan 2023, and this question came out this last JUPEB exam. The chemistry they did, the final JUPEB exam that they just concluded. This question came out in the chemistry. Why do atoms undergo chemical bonding? Write it down. Why atoms undergo chemical bonding? Why atoms or ions undergo chemical bonding? Why atoms or ions undergo chemical bonding? Why do you have atoms or ions undergoing chemical bonding? Number one, to achieve stability. To achieve stability. I will explain. Number one, to achieve what? Atoms undergo chemical bonding or ions undergo chemical bonding to achieve what? Stability. What is stability in chemistry? Stability in chemistry. Take note. Stability in chemistry. Don't cram it. When you hear the word stability in chemistry, what is stability? Let us stop writing. Stability in chemistry is when atoms achieve what? Octets or duplets. Take note. That means when atom has 8 electrons on its atomic shell, or 2 electrons on shell, K shell. That is duplet. 2 electrons on K shell, which is the last electron, on K shell, which is the last shell. Stability is when atoms of octets, that is having 8 electrons. This one, octet means what? 8 electrons on the outermost shell. Take note. Stability is when atoms have 8 electrons, that is form octet. 8 electrons on the outer, or form duplet. Duplet means what? When you only have 2 electrons on the K shell, and that K shell must be the last shell. Take note, K shell can only take 2 electrons. K shell can only take 2 electrons. You are still coming to that topic under quantum number. K shell can only take how many electrons? 2 electrons. When you have 2 electrons on K shell, and then if that K shell is the last shell, that means the atom has formed what? Duplet. That means the atom was stable. Stability means what? Formation of octet or duplet. Then that is one of the reasons why atoms undergo chemical bonding to form what? To achieve what? Stability. To achieve stability. Please, this one is 2023. Yeah. 2023. Number two. This one is the one that came out in what? JUPEB. Number two. To have lower potential energy. Have low or lower potential energy. To have lower what? Potential energy. To have lower what? Potential energy. Take note. When an atom is stable, the potential energy will be low because it has attained what? Stability. The energy will be what? Low. That's one of the reasons why atoms or ions undergo chemical bonding. Once they are stable, don't forget, when you are rich, you will be walking from one point to another, you'll be stable. That is why atoms, when they form what? Chemical bonding, they are stable, they are rich. Therefore, they will have ifocombane. That ifocombane is what? They lower their potential energy. Everything will be calm. Take note. To have lower potential energy. Number three. Number 4. To have electronic configuration of noble gases. To achieve electronic configuration of noble gases. To achieve electronic configuration of noble gases. Take note of this, especially group F student, A-level student. To achieve electronic configuration of noble gases. To achieve electronic configuration of noble gases. To achieve electronic configuration of noble gases. Class, I will explain this one also. Anything we give here, we explain. Anything we give, we explain. So that you don't cram. Here in neotisa, you don't cram, you don't understand. So that even though you forget, when you see question on it, you can easily remember. You understand? I said the third atoms or ions undergo chemical bonding is to have electronic configuration of what? Noble gases. What are noble gases? That is group 8 elements. Group 8 elements. Or group 18 or group 18A. Group 8 elements. They are called group 8 or 18A. What are the noble gases? We have helium, neon, argon, xenon, krypton. Oh, you have krypton rather. Xenon. You have random. You have organism. These are group 8 elements. This one, helium, take note. Helium, the first one. Helium, the chemical symbol is helium is the only one that forms duplex. Hey, take note. Helium is the only one that forms what? Duplex in group 8. Duplex is to have 2 electrons on the what? K shell. And that K shell must be what? The last shell. He only has one shell, and that shell is K shell. This helium only has how many shells? And that one shell is what? K shell. And that K shell is the last shell. They only have 2 electrons on it. It's the only element in group 8 that form what? Duplex. That means it's stable by having 2 electrons on K shell. It only has one K shell, one shell, which is K shell, one shell, which is K shell. Then the other, they form what? Octet. This other one, from neon to organism. This one was discovered in 2010. Organism. From neon to what? Organism. They form octet. That means they have 8 electrons on the what? Outermost shell. Then all other elements, apart from hydrogen. Take note of this statement I want to give you also. Take note of this statement. Apart from hydrogen, hydrogen is the only element that can also form one duplet when it undergoes chemical bonding. Write it down, class. Write it down, class. Class, write it down. Hydrogen is the only element. That can form what? Duplet when it undergoes what? Chemical what? Bonding. Hydrogen is what? Is an element or the only element that can form what? Duplet when it undergoes chemical bonding. Hydrogen is the only element that can form what? Duplet when it undergoes what? Chemical bonding. Helium is already duplet, it's stable. But if hydrogen undergo chemical bonding, it will have the stability of what? Helium. Take note, that's what I mean. When hydrogen undergo chemical bonding, it will form what? Stability of what? Duplet of helium. I repeat myself. Helium form duplets. It has 2 electrons on K shell. Abi? Isn't it? It's the only element here in group 8 that has 2 electrons on K shell. Then which other element can form duplet? Hydrogen. When hydrogen undergo chemical bonding, it will form the stability of what? Helium. That means forming what? Duplets. Why other elements? For them to undergo chemical bonding, they will form what? Octets. They will form the stability of neon to what? Organism. All other elements. Then the third reason why I said why atoms undergo chemical bonding, the third reason, to have electronic configuration of what? Of what? Noble gases. What are the electronic configuration of noble gases? Take note of it. NS2, NP6. I told you 2 plus 6 is what? 8. How many electrons? 8. I told you the number on top is what? Electron. This one is what? Number of shell, energy level. When I told 2s2, for example, or 2p6 or 2p4. This 2 is what? Shell, energy level. Why this 4 is what? Number of what? Number of what? Number of what? Electron. Take note. Now this P can be found in shell. That's the meaning. And this P has how many electrons? This P can be found in what shell? This P has how many electrons? If I write 1s2, this S can be found in what shell? The first shell. And this S has how many electrons? If I write 4p6, this P can be found in what shell? In what? Fourth shell. This P has how many electrons? 6 electrons. Then that means this S can be found in what? N shell. Nth shell. And this S has how many electrons? 2. This P can be found in what? Nth shell. This P has how many electrons? 6. Then how many electrons together? 8 on the outermost shell. Which would be 2s2, 2p6. That is electronic configuration of neon. Neon is what? 2s2, 2p6. For argon is what? 3s2, 3p6. For krypton is what? 4s2, 4p6. Do you understand? Now means for atoms to undergo chemical bonding, they must have the electronic configuration of what? Noble gases. What is the electronic configuration of noble gases? NS2, NP6. Write it down. Write it down. Hope you are following. Hope you are following. Please, if you follow, please thumb up on this live streaming platform. On the live streaming platform. On the live streaming platform. Please. Hope you are following. It's simple, Abby. It's simple. Simple. Please. Class. For atoms to undergo chemical bonding, for them to be what? Stable. 2. To have lower what? Potential energy. 3. Electron configuration of what? Noble gases. Which is what? NS2, NP6. Then let's go to types of chemical bond. Types now. Types. 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 Types of chemical bond. Types. Types of chemical bond. Types of chemical bond. Please, types of chemical bond. Types of chemical bond. Types. Please, those people online, follow everything in chemistry and physics are very simple. Chemistry, physics are very simple. I don't know why students are struggling. The struggle starts from SS1, because of teachers taking you the subject. They don't give you the basic things you have to know. That's why most of you struggle. You want to study medicine, nursing, and at the end, when you are struggling with physics and chemistry, those are the science, the core science, not even biology. Because biology, people look at biology very simple. It's just read. But chemistry and physics, they are the main core. And once you struggle with those two, you'll be able to get your medicine, nursing, pharmacy, dentistry, Unilab or any other school. Even in private university, they don't play with medical courses. But with us, settled. Types of chemical bonding, right? Types. We have two types. Two types of chemical bonding. Two types. Two types of chemical bonding. Two types. We have two types of chemical bonding. Two types. Two types of chemical bonding. Two types. Two types. We have, take note of this one, that is not the way they gave you in school, but that is where you will see it in Cambridge A level, DUPED, and in JAM. This is where you will see it. But the way they taught it in all schools in secondary level, that is not the way I want to give it to you. That's why you have to listen. You have two types of chemical bonding. Two types. We have interatomic bond. Interatomic bond. And we have intermolecular force. This one is not a bond, it's a force. It's not as strong. It's not. Look at it as an interatomic bond, intermolecular force. I call it intermolecular force because it's not strong enough to be a bond. I call it intermolecular force. It's not strong enough to be a what? Bond. Take note of that statement. I have interatomic bond, intermolecular force. Intermolecular force is not strong enough. It's not strong enough to be a bond. A bond must be strong. Before you can break a bond, there must be high supply of what? Energy. But this one is not strong enough. That's why they call it force, intermolecular force. Even though bonds are forces, bonds are what? Forces. But there are some forces that are not enough to be a bond, which are what? Intermolecular force. Take note of that. Take note of that. Interatomic bond, we have ionic bond. Ionic bond, also known as electrovalent. Electrovalent bond. Also known as electrovalent bond. We have covalent. Covalent. Also known as molecular bond. Molecular bond. We have dative bond, also known as coordinate bond. And we have metallic bond. They are called primary. You can also call them primary bond. Very strong bond. Take note. Primary. Take note of that. Take note. We have intermolecular force. We have bond. Let me start with hydrogen. Hydrogen bond. They call it hydrogen bond, but it's not strong enough to be a bond. Hydrogen bond. HB. Hydrogen bond. Hydrogen bond. Very important bond. Very important. Very important. We have Van der Waal. Van der Waal, the weakest. Van der Waal, the weakest force of attraction. Is the weakest. Is the weakest. Is the weakest. This Van der Waal, when you get to what? A level, it can be divided into three. London dispersion, dipole, and dipole-induced dipole. It can be divided into three. Then it can further be divided into what? 5 again, but you don't need that. Just 3, scientifically, 3. Take note of that. But for O level, you don't need to disturb your play. Write it down. If they ask you, between interatomic bond and intermolecular bond, which one is the stronger one? The answer is what? Interatomic bond. Write it down. Interatomic bond is stronger than intermolecular force. Take note. Interatomic bond is stronger than intermolecular force. Interatomic bond is stronger than intermolecular force. Then some people, it's a debate. Among this one now, which one is the strongest? You can't say particular one is stronger than particular one. No. Some people say ionic bond is stronger than covalent bond. But there are some covalent molecules that are stronger than ionic. Example, diamond is the strongest, the hardest substance. Diamond. That is, this one depends on the what? The compound. You can't say one is stronger than one. Just take note of that. Just take note of that. Those people online, please, hope you are following. Please say yes to the group. Yes, please just say yes to the group. How many thumbs up do you have to show that you are following? Please. Okay, let's do now. What is interatomic bond first? I will give you interatomic bond, then do one of these, and do each of these rather. Then I will give you let me give you the meaning of interatomic bond, and let me give you the meaning of intermolecular force before I start taking one of them. Right, interatomic bond. Right. This is the force of attraction. This is the force of attraction. Interatomic bond, which is primary bond. This is the force of attraction. This is the force of attraction. This is the force of attraction that occurs within atoms. That occur within atoms. That occurs within atoms. To form molecules or compound. To form molecules or compound. To form molecules or compound. To form molecules or what? Compound. To form what? Molecules. It occurs within atoms. Within atoms. It occurs within atoms to form molecules or compound. Then what is intermolecular force? This is the force of attraction. This is the force of attraction. This is the force of attraction. That occurs between separate molecules. Look at that. Between separate. If they say interstate, from one state to another. Interstate, one state to another. Intercountry, one country to another. Intermolecular force. Force of attraction that occur between separate molecules. Between what? Separate molecules. It occurs between separate what? Molecules. Take note. It occurs between what? Separate what? Molecules. Take note of that. Take note of that. Then let's take them one by one. Let's go to what? Ionic bond. Ionic bond. Ionic bond. I won't need to give you go down to bed level. I won't need to go down to A level. Because for the entrance exam, Japan entrance exam, you don't go down. But when you get to the program, there are so many things you do under this. Into the program, there are so many things. But for the entrance exam, what you need is what I will give you. You understand? You understand? Because when you are doing A level or Japan, I'm not talking about SS3, JAM, entrance exam, Japan entrance exam. I'm not talking. You are doing Japan A level, real A level. You will do lattice energy under this. You will be Haber bomb principle under this. You do Fasan theorem, Fasan principle rather, Fasan principle under this. You do so many things under ionic bond. But for entrance exam, you don't need much. You don't need. But when you get to the program A level, you see more. Take one, ionic bond, the first one. Ionic bond. Let us try. Ionic bond. Ionic bond. Right. This involves transfer of electron. This involves transfer of electron. This involves transfer of what? Electron. Between atoms. It involves transfer of what? Electrons between atoms. It involves what? Transfer of what? Electrons between what? Atoms. It involves transfer of electron between what? Atoms. Transfer of electron. When they say transfer of electron, that is what? Electrovalent bond, ionic bond. Transfer of electron. What do they mean by the transfer of electron? One atom loses electron. The other atom what? Gains electron. Do you understand? Involves transfer. If you transfer money, what happens to it? Somebody will be debited, Abi, and someone will be what? Credited. Someone that is debited is losing, Abi. Someone being credited is what? Gaining. That is why they say transfer of money, Abi. The same thing, it involves transfer of what? Electron. Someone will be losing, one atom will be losing, and another atom will be what? Gaining. The atom, write it down, the atom that is losing is called reducing agent. The atom losing electron is called reducing what? Agent. Write it down. Which are metals? Which are what? Metals. Write it down. Write it down. The atoms losing electron is called what? Reducing agent. The atoms losing electron is called what? Reducing what? Agent. Like the man losing money. Transfer of money. Someone will be losing money, someone will be gaining the money. The same thing, transfer of electron. Someone is losing the electron, someone is gaining the electron. The atoms that is losing the electron is called what? Reducing what? Reducing what class? Agent. And which are what? Metals. Which are metals? 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 Comma. The atom gaining electron. The atom gaining electron. Thank you. The atom that is gaining electron is called oxidizing agent. Oxidizing agent. Oxidizing agent. The atom that is gaining electron is called what? Oxidizing agent. Which are what? Non-metals. Which are non-metals. which are non-metals. The atom that is gaining electron is called oxidizing agent, which are non-metals. Can I rub on this? Yes. Let me rub it off. Please. Okay, class. Now, you know the meaning of electrovalent bond. Another name for it is ionic bond. Ionic bond involves a transfer of electron. One atom loses, one atom gains. The one that is losing electron, reducing agent, which is metal. The one that is gaining electron, oxidizing agent, which is what? Non-metal. That means electrovalent bond occurs between what? Metals and what? Non-metals. Write it down. It occurs. Electrovalent bond occurs between metals and what? Non-metals. Electrovalent bond occurs between metal and non-metal. That is where you have metal reacting with non-metal. The bond that will be formed is what? Electrovalent bond. When you have metal combining with non-metal, the bond that will be formed is what? Electrovalent bond. Are you following? Which one is losing electron? Metals. Which one is gaining electron? Non-metal. Oh yeah. Do you understand? That means when I have sodium plus chlorine gas to give sodium what? Chloride. That means metal and what? Non-metal. They form what? Sodium chloride or compound. In this compound, what bond will occur? What bond occur in this compound? Electrovalent bond. Ionic bond. This ionic bond compound, sodium chloride. This thing, the problem is that some of you don't know how to identify metals and non-metals. And I've taught you that. We've done that last week. How to identify metals and non-metals. We've done that last week. That's why I told you, before we go, I need to teach you those basic things, which I've done. The only basic things I haven't taught you is how to name compounds, how to write chemical formula, which will be done maybe this week it will be done. But this topic, you need to treat it. Okay, let's read. For example, when you have calcium plus oxygen gas to give calcium oxide, that means metal plus what? Non-metal to give this compound. What bond will occur in this compound? Ionic bond. Calcium is losing electron. Oxygen is what? Gaining electron. In what way? Let me illustrate with this. Let me illustrate. Let me illustrate. This is what they mean. When you have sodium, you understand? Combining with what? Chlorine. That means this is sodium. Let me use sodium only. For sodium to be stable, it needs to what? Lose electron, isn't it? For sodium to be stable, it needs to what? Lose electron. Look at this. Hydrogen, lithium, sodium, potassium, beryllium, magnesium, calcium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, helium, neon, argon. Periodic table of the first 20th element. I've given you this before, but I want to use it for something. Look at this. Fluorine, chlorine. This is group 1, group 2, group 3, group 4, Group 5, group 6, group 7, group 8. This is sodium. Sodium can be found in what group? Group 1. Group 1. How many electrons on the outermost shell? 1. I told you, elements in group 1, they have 1 electron on the outermost shell. Elements in group 2, they have how many electrons? 2. That's how. Group 1 element, they have 1 electron on their outermost shell. And for element to be stable, it must form what? Octet, abi? Octet means what? How many electrons? 8. But it has only 1. It cannot gain the 8, the remaining 7. Rather, it cannot gain the remaining what? 7. Nobody will give him 7. But he can do something for himself to lose what? The 1 electron. So that it will be what? Stable. It will now lose the 1 electron to sodium what? Ion. Losing 1 electron. If you lose the electron, you become plus. If you gain electron, you become what? Negative. Let that thing be in your head in chemistry. When atom loses electron, it becomes what? Positively what? Charged. When atom gains electron, it becomes what? Negatively charged. He lost 1 electron, it becomes plus 1. If you lose 2 electrons, it becomes what? Plus 2. Are you following? If you lose 3 electrons, you become what? Plus 3. If you gain 1 electron, you become what? Minus 1. If you gain 3 electrons, you become what? Minus 3. Then it's combined with chlorine. Chlorine can be found in what group? Group what? 7. Group 7 means they have how many electrons on the atomic shell? 7 electrons. For this one to be stable, it needs how many electrons? Just 1. This one can easily gain 1. You need 1 error to balance your transport field. I can easily give you 1 error. You understand? It will gain the 1 electron to become chloride ion. Do you understand? Then what happens? Sodium combined with what? Chlorine. That is have sodium plus chlorine to form what? Sodium what? Chloride.
So did that E?
Yes, if you add them, E cancel what? E. Do you understand? That means they are called ionic compound. I told you electrovalent bond is also known as what? Ionic what? Ionic what? Ionic bond. Abi? Electrovalent bond can also be called what? Ionic bond. That means the electrovalent compound can form ionic compound. Ionic compound. That's why they are called ionic bond. Do you understand? Do you understand? Now, sodium is stable, Abi. Chlorine is also what? Stable. Do you understand? That is that. Take note of that. Take note of that. Take note of that. In entrance exam, they will just ask you to give you in this compound what bond occur. They will give you the compound. When you see a compound, first of all, identify the metal, identify the non-metal. If you see metal and you see non-metal, what bond? What bond is that? Ionic bond, electrovalent bond. And elements in group 1, they are metals. This one is not a metal except of hydrogen. Hydrogen is what? Non. All other elements in group 1 are what? Metals. Elements in group 2, they are what? Metals. Elements in group 3, they are metals. Apart from boron, which is what? Metalloid. You have 3 types of elements. How many types of elements? How many types of elements? Metal, non-metal, metalloid. You understand? 3 types of elements. Metal, non-metal, metalloid. 3 types of elements. Metal, non-metal, metalloid. Boron is what? There are all these elements in group 4. This one. Carbon is what? Non-metal. Carbon is what? Non-metal. Silicon is what? Metalloid. Silicon is what? Metalloid. Why all this one, they are what? They are what? That means you can now identify metals and what? Non-metal. But when you see transition elements, all transition elements are metal, so all transition elements, they are metal. Zinc, copper, silver, gold, mercury, cobalt, chromium, manganese. This one is magnesium, manganese, iron, nickel, All these ones, they are metals also. All transition element are what? Metals. Take note of that. Take note of that. That means in nano, look at this. In this compound, class, if you are aluminium oxide, what bond will occur in this compound? Aluminium is what? Metal. Oxygen is what? Non-metal. When you are calcium nitride, what bond? What? Calcium nitride, ionic bond, that is electrovalent bond. Calcium is what? Metal. Nitrogen is what? Non-metal. When you are methane, what bond? It's not ionic. Abi? It's not. Carbon is what? Non-metal. Hydrogen is what? Non-metal. We are still coming to that. That's bond. We are coming to that. You understand? Do you understand? Do you understand? Take note of that. Take note of that. Class, there is a question in JAM. Option A, they put sodium chloride. B, they put magnesium chloride. C, aluminium chloride. D, they put potassium chloride. Please write this question and write this option. I want to explain something. Which of the following ionic compound, which of the following compound has the least ionic character? Which of the following compound has the least ionic character? Which of the following compound has the least ionic character? Which of the following compound has the what? The least ionic what? Character.
I'm going for D.
You are going for D, okay? I'll explain. Which of the following compound? I will tell you how to. In JAM, they can't go beyond this. But in JUPEP exam, A-level exam, in the entrance exam of JUPEP, they can't go beyond this. But when you do the program after 10 months, we want to do the real exam, they will go beyond this. We use Fassan's rule to get this question answer. Fassan. But at this level, you don't need that. There's a simple way you can use to know the answer. The least ionic character, they can't go beyond this. They will have the same negative or non-metals. They can't go beyond that. They can't go beyond this. For all level, they can't go beyond it. They can't. Which of them we have the least ionic character? That is electrovalent word character. The least ionic character means what? The least word electrovalent character. This is how you know. Just find the one among the metals. Sodium is a what? Magnesium is a what? Metal. Aluminium is a what? Metal. Potassium is a what? Metal. They have the same non-metal. Just look at the metal. Sodium is a metal. Magnesium is a metal. Aluminium is a metal. Potassium is a metal. Among the metals, find the one that has the highest number of electrons on its atomic shell. Sodium can be found in what group? Group 1. How many electrons do they have on their atomic shell? 1. Magnesium can be found in what group? Group 2. How many electrons on their atomic shell? 2. Potassium can be found in what group? Group 1. How many electrons on the atomic shell? 1. Aluminium can be found in what group? Group 3. How many electrons on the atomic shell? Which one has the highest number of electrons on the atomic shell? Aluminium. Therefore, since it has the highest number on its outermost shell, it will have the least ionic character, which was chloride. This one has the least ionic character. We use Fassan's principle.
is an ion carbon.
The one that has the highest number of electrons in its outermost shell, in an atomic form, in an atom form. The one that has the highest number of electrons in the outermost shell. It has the least ionic character. 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 Please take note of that. They can't go beyond this question. In entrance exam, in any entrance exam, take note. Right, characteristics of ionic compound. 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 Please, class, if you understand that question, please drop a comment, and if you don't understand, drop a comment on the group's chat. Please let me know. If you can understand that question, drop a comment, please. Characteristics of ionic compound. Number one, 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 they are solid in physical state. 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 They are solid in what? Physical state. Number two. Class, let me explain that. I said they are solid in what? Physical state. Look at your table salt. Your cooking salt at home. It is known as your sodium chloride. Your cooking salt, your table salt, sodium chloride. At that state, is it solid?
Yes.
Your salt, is it solid? Yes, it is solid. Why? Because it's an ionic compound. They are solid in physical state. Their physical state is what? Solid. All ionic compounds, their physical state is what? Solid. Number two, they are soluble in polar solvents. They are soluble in polar solvents. Example of polar solvent is water. They are soluble in polar solvent, such as water. They are soluble in polar solvent, such as what? Water. They are soluble in what? Polar solvent, such as what? Water. Class, if they ask you, for example, what is a polar solvent? What is a polar solvent? What is the meaning of polar solvent? A question that you have to know. That is there in your past question, but when you see it, you now be struggling with polar solvent. What is polar solvent? What is polar solvent? What is not polar solvent? What's the meaning of polar solvent? Polar solvent. A solvent that has both positive and negative pole. Write it down. A solvent that has both positive and negative pole. Both positive and negative pole. Water, as an example, has both what? Positive and negative what? Pole. Positive and negative pole. Any solvent that has positive and negative what? Pole is known as a polar what? Solvent. In polar solvent. Number three, they can conduct electricity. They conduct what? Electricity in solution state. In solution state. I didn't say in solid state, in solution state. They conduct electricity in solution state. That is only state they can conduct electricity. In solid state, they can't conduct electricity. In solid state, they cannot do what? Conduct electricity. They can only conduct electricity in what? Solution state. That means, open a bracket, aqueous. in aqueous state. Aqueous. That's the solution state. In aqueous state. The conduct current in our solution state in aqueous. Number four. They have high melting and boiling point. 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 Number five. They can be extracted by electrolysis process. They can be extracted by electrolysis process. They can be extracted by what? Electrolysis process. They can be extracted by electrolysis process. They can be extracted by electrolysis process. Take note of that. Class, another question. Hey, this is a nice question. Hey. Which electron, they will ask you, take this question. This is Java question. Which electron is responsible for the formation of chemical bonding. A. Valence electron. B. Core electron. C. Inner electron. D. None of the above. Take this question. Very important question. Which electron is responsible for the formation of chemical bonding? Which electron is responsible for the formation of chemical bonding? Which electron is responsible for the formation of chemical bonding? The answer to this question is valence electron. Why? Valence electron is outermost electron. The electron on the last shell. Huh?
To be valence, the number of the electron.
The number of electron or the electron on the last shell. The electrons, it could be one, it could be two. We can call valence electrons if they are more than one on the last shell. Class, look, what is valence electron of group 1? Let us listen. What is valence electron of group 1? 1. They have one electron on the outermost shell. Valence electron of group 2. 2. Valence electron group 3. 3. They have 3 electrons on the outermost shell. If they say which electron is responsible for formation of chemical bonding, is what? The outermost electron. That is the valence electron. Electron on the outermost shell, on the last shell, is responsible for formation of chemical bond. Do you understand? Let's go. Next one. Molecular bond. Number 2. Molecular bond. Let's move. Molecular bond. After the definition of molecular bond, we call it a day on chemistry. You can prepare for mathematics because of the Jupep student. Yes. Huh? Yes. Please take note. Then tomorrow it will be physics. The Jupep student will do our government tomorrow. I will teach our government tomorrow. Okay, let's move on. Molecular bond now. Molecular bond. Don't forget, another name for molecular bond is what? Is covalent bond. Covalent bond. Covalent bond. Let's go to covalent bond. Covalent bond. Covalent bond. Covalent or molecular. Molecular bond. Covalent bond or molecular bond. Right. This involves the sharing of electron. Sharing of what? Electrons. This involves sharing of what? Electrons. Involves sharing of what? Electrons. Which can lead which can lead to overlapping, of orbitals, which can lead to overlapping of what? Orbitals. This involves the sharing of electrons, which can lead to what? Overlapping of what? Orbital. Overlapping of orbital. Class. In this one, there's no transfer of electrons. None of them is losing. None of them is gaining. Not like ionic bond or electrovalent bond. One will lose, one will gain. No. This one, I don't want to lose. She doesn't want to lose. I want to be stable. The only thing we can do is to come together as one share electron. None of us, we don't want to lose. But since none of us want to lose, the only thing, let us come together. Let us share the word electron so that we can be stable. That's why covalent bond involves what? Sharing of what? Electron. It occurs when non-metal combine with non-metal. It occurs when non-metal combine with non-metals. It occurs when non-metals. In this one, you will learn so many things. Occur in it. But you won't learn it as you will learn it in what? In A level in Japan. That one you have to. For this one in Japan, it's even harder than ionic bond. Covalent bond in Japan is harder than ionic bond. Well, under covalent bond in Japan, you will do so many things. That is what they call chemistry. And once you can understand chemical bonding, your chemistry is standard. You are standing. Once you can understand chemical bonding, because that's what they call it chemical. Without chemical bonding, there can never be chemical reactions. There can never be chemical reactions. There can never be formation of compound. Because atoms come together to form what? Compound. And compound is formed by what? Chemical what? Bonding. When you know this topic, you are grounded in chemistry. You are grounded in chemistry. You are grounded in chemistry. Grounded. Okay, I said covalent bond involves what? Sharing of electron. It occurs when non-metals combine with what? Non-metals. When non-metals combine with what? Non-metals. Let us stop. E.g. formation of molecules of gases. That's where we are going to stop. Formation of molecules of gases. Formation of molecules of gases. Formation of molecules of gases. Formation of molecules of what? Gases. Formation of molecules of what? Gases. That means in molecules of gases, if they ask you, what kind of bond occur in it? Class, in molecules of gases, what kind of bond occur in it? covalent bond. Covalent bond. In molecules of gases, whenever you hear molecules of gases, the kind of bond that occur in them is called covalent bond. Formation. Roman figure 1 under that. Hydrogen gas. 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 Hydrogen gas.
Oh, okay. You know what company No, okay.
No. Hydrogen gas. Hydrogen gas. No. Hydrogen gas. Hydrogen.
Oh, my. Oh, come on. That was one.
Wow. That is one. Hydrogen gas. Okay, let us look at it. When you have hydrogen plus hydrogen to form hydrogen gas. Please let me explain. Huh? Listen, you have to understand this hydrogen gas. You have to understand, after this one, call it a day. Please, on chemistry, look at this. I want you to understand something. This hydrogen is not stable. This is one atom of hydrogen. This is another one atom of hydrogen. It's not stable. For both of them to be stable, they need to come together and share electron. When they now come together to share electron, they form what? Hydrogen gas. Listen, look at hydrogen. It can be found in group 1. He has one electron on the wall, outermost shell. And he has only one shell. I told you, elements in period 1, hydrogen, helium, they are in period 1. How many shells do they have? One shell. Element in period 2, how many shells? 2 shells. Element in period 3, period is horizontal, group is what? Vertical. Period is what? Horizontal, group is what? Element in group 1 have one electron. One electron. Group is number of electron. Period is number of what? Shell. Group is number of what? Electron. Period is number of what? Shell. Element in period 1 have how many shell? 1 shell. Element in period 2, how many shell? 2 shell. Element in period 3, how many shell? 3 shell. Element in period 4, how many shell? 4 shell. That is hydrogen and helium, they have only 1 shell. They are in period 1. But this hydrogen is found in group 1. He has 1 electron on the atomic shell. That means he has only 1 shell with 1 electron. And for this hydrogen to be stable, it needs to form duplets. Like what? Helium. Helium has 1 shell, then you have 2 electrons on that 1 shell. And I told you, when you form duplet, 2 electrons on 1 shell, which is K shell, and that K shell is the last shell. When you have 2 electrons on K shell, which is the last shell, that means you form a duplet. But for this hydrogen, it has only 1 electron in that K shell. It's supposed to have 2 electrons in K shell to be stable, to form duplets. But it has only 1. It needs to combine with another one, hydrogen, that has 1 electron in that K shell. They will now come together to share the electron. They now came together. They came together to share the electron. That is pack. That means for this hydrogen, how many electrons? 1, 2. For this hydrogen, how many electrons? 1, 2. That means they are now stable. This is the structure of what? Hydrogen gas. Take notes. Take notes. If you understand this, you have understood covalent bond. You have to understand. Please. Covalent bond is other than ionic bond. It's other than ionic bond. More complex than ionic bond. But it's very simple. Very simple. Take note. Take note. Shear is called shared electron. Shared electron. Or covalent bond electron. Or covalent bond electron. Take note. electron that is being shared is called what? Shared pair electron. Shared pair electron or shared electron. Shared pair, pair means for two. When you have one thing that has two, pair of what? Shoe. That means you have two different ones, but a pair. Shared pair electron. Then this thing, these two electrons they share is called what? Pair. Shared pair electron or shared electron. This thing means one line. These two electrons means what? One line. When you see a line, it means what? Covalent bond. If I want to draw this hydrogen, I can say hydrogen. That means this line means how many electrons? Two electrons. That means 1, 2 for this hydrogen. 1, 2 for this other one, hydrogen. That means hydrogen, is this a single bond or double bond or triple covalent bond? Hydrogen is for single or covalent bond because it has for just one line, single. That means two electrons forming a pair, a shared pair, a shared pair. Two electrons that are shared are what? A shared pair, which was these two electrons is what? One line, which is what? Hydrogen is a what? Single what? Covalent bond. Do you understand? Single covalent bond. Single covalent bond. Please, if you understand, if you don't understand, please drop comment. So that I can quickly re-explain.
So if this same covalent bond is still on that organic chemistry.
Yes, ma'am. You have to understand covalent bond before you understand organic chemistry. Very well. If you don't understand covalent bond, you don't kind of understand organic chemistry. Let's say if you want to crack covalent bond, chemical bonding is chemistry. Is the chemistry. I could remember the man that taught us. He said that then you don't need to know. I will only teach you 5 topics. The first one is chemical bonding, periodicity, calculating aspect of chemistry, electrolysis, and what? Organic chemistry. That is what they taught us then that made us to understand chemistry. Those 5 topics. The other one you understand. Once you understand those one, I can show that. Okay, next one now. Next one. Slide on this one. Formation of the Roman figure 2, oxygen gas, oxygen gas, oxygen gas, oxygen gas, oxygen gas, oxygen gas, oxygen gas. That means oxygen molecule. Oxygen gas means what? Oxygen molecule. Whenever you hear oxygen gas, that is oxygen molecules. Hydrogen gas, hydrogen what? Molecules. Chlorine gas, chlorine what? Molecule. Nitrogen gas, nitrogen what? Molecules. In all of them, what bond? Covalent bond. But what I want to teach you is this single covalent bond, double covalent bond, triple covalent bond. That's what I want to. But you know that this one is for single because we only have a shared pair what? Electron. Let's look at oxygen. Now this way you have O plus O to give you what? O2. O2. O plus O to give you O2. O plus O. Oxygen plus oxygen. One atom of oxygen plus one atom of oxygen to give you what? 2 atoms of oxygen. This one is not stable. This one is not what? Stable. For them to be stable, they now come. Let us share electron. And let us form what? Oxygen molecules so that they can both be what? Stable. They now come together. They share electron. They are now what? Stable. They lower their potential energy. They form stability. And they achieve what? Global gas electronic what? Configuration. Then how do they do it? Look at it. Oxygen can be found 1, 2, 3, 4, 5, 6, 7, 8. What is atomic number of oxygen? 8. That means electron number is what? 8. You can find one group. Group was 6. Group what? 6. 1, 2, 3, 4, 5. Group what? 6. Now this group 6 has how many electrons on the atomic shell? 6. Abi? The atomic number is 8. Abi? Electron number is 8. They have 6 electrons on the atomic shell. That means if I draw it, this let me clean this one up so that because of the diagram, let me clean this one. Let me clean this one. You have O plus O will give you O2. Therefore, oxygen atom, that is, you have 2 electrons, then 6 electrons on the atomic shell. 6 electrons. 6 electrons. This is 6. Are we following? Make how many electrons altogether? 8. 1, 2, 3, 4, 5, 6, 7, 8. Atomic number of oxygen is what? 8. This is what? These 2 electrons are inside of it. They are called core electrons. They are called what? Core electrons. Electrons inside are what? Core electrons. They are known as what? They are known as what? Core electrons. Electrons that is inside are called core electrons. Electrons on the atomic shell are called valence what? Electron. Take note. Take note. Electron inside. These 2, they are inside. They are core electron. Core electron. Then the one on the atomic shell is called valence electron. Do you understand? Core electron. The one inside. The one on the atomic shell are called what? Valence what? Electron. Valence electron. Valence electron. It has 6 valence electrons. Then plus another oxygen. Adi? Core electron. Then 6 valence electron. 6. Class now. For oxygen to be stable, it must have 8 Abi. But it only has what? 6 Abi. It only has 6 Abi. Or he only has 6. Isn't it? For it to be stable, we must have 8 on the atomic shell, isn't it? But it only has what? 6. It needs extra what? 2. It needs extra what? 2. Then what do we do? This one, they are already paired. This one is already paired. That's why you have to fill in 4 places. Look at the way I drew my own so that you understand. Atomic number of oxygen is 8. The inner electron can only take 2. K shell can only take what? 2. Remaining how many? 6. In 4 places. 4. In 4 places. Remaining what? 2. Then pair it. Do you understand? Then for it to be stable, it needs extra 2. This one needs extra 2. This one also needs what? Extra 2. Isn't it? Then they will now come together. They came together. Let me put the one inside. This is the one inside. Then these 2 that is already been paired. This is it. The 2 that is already been paired. Then this 2 that is already been paired is this one. These 2 that is already been paired. Then this one that is not paired is one that they will now come and share. They will now come and share it back. Do you understand? Do you understand? These 2 that is already been paired, 1, 2. These 2 that is already been paired, 1, 2. This one that are not paired is one they will bring out. And they now come. Then look at it, oh, class. Online. Look at it. How many electrons for this oxygen? 1, 2, 3, 4, 5, 6, 7, 8. How many electrons for this oxygen? 1, 2, 3, 4, 5, 6, 7, 8. It's not stable. Then class, how many covalent bond electron is oxygen? I told you 2 electrons means what? Single Abi, 1 line. 2 electrons means what? 1 line. How many lines are you going to have for this one? 2 lines. That is oxygen. That means these 2 electrons, 1 line. This another 2 electrons, 1 line. These 2, 1, 2, 1, 2. These 2, 1, 2, 1, 2. That means for this one, how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. For this one, 1, 2, 3, 4, 5, 6, 7, 1, 8. That is oxygen. Is it double covalent bond, triple covalent bond, or single covalent bond? Class. The answer is what? Double. Double covalent. Double covalent. The last one, nitrogen. Those people online, please, if you can't understand, ask question on the group so that I can be explained before we go to the last one. Please. How many people are online? 4. 6, 4 there. One person is moving and coming in. The person should be stable. You people should be stable.
Chemical bond.
What?
That person should be a chemical bond. It's not
Yeah. You have to be a chemical bond. So you have to be stable. You have to form stability. Okay. Next one. Number 3. Nitrogen gas. Number 3. Number 3. Nitrogen. You've done it.
No.
Nitrogen gas. Number 3. Nitrogen gas. Let us look at it. Next one. Nitrogen. Number 3. Nitrogen gas. Nitrogen gas. N2. Nitrogen gas. N2. Nitrogen gas. N2. Nitrogen gas. Look at it. The same way. N plus N will give you what? N2. Now this nitrogen is not what? Stable. This one too is not what? Stable. Let us listen so that you can get it once. Stop writing. Not stable. They will now come together to form covalent bond to be stable. This nitrogen can find one group. Group 5. It has how many electrons on the atomic shell? 5. You can find 5 nitrogen. 5 electrons on the atomic shell. What is the atomic number of nitrogen? 1, 2, 3, 4, 5, 6, 7. Nitrogen is what? 7. Atomic number of what? 7. Now this electron number is also what? 7. If I draw it, the inner electron, called electron, 1, 2. Then remaining how many electrons? 5. 1, 2, 3, 4. Abi? Remain how many? 1. Clear this one. 1. Do you understand? Plus another nitrogen. Inner electron, 2. Remaining 5. 1, 2, 3, 4. The remaining one, clear it with it. Abi? This one is only to be stable. 3. To make it 8, Abi?
Yes.
He has 5 on the atomic shell. He needs extra 2 to have 8 on the atomic shell. Has 5 on the atomic shell. He needs extra 3 to be stable, Abi? Then they will now come together. They come together. They come together. This is they come together. Let me draw the inner. This is the inner one. They come together. Then this one that is already been paired, put it here. This one that is already been paired, put it here. These 3 single one is one they will come and share. These 3 single one, do you understand? Do you understand? Then look at this. How many electrons for this one? 1, 2, 3, 4, 5, 6, 7, 8. For this one, how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. And I told you, 2 electrons that is shared. This one wall, 1 line, a PRB. That means how many lines are we going to have in this one? How many? 3 lines. 1, 2, 3. Then these two. Therefore, how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. For this one, 1, 2, 3, 4, 5, 6, 7, 8. Therefore, nitrogen is it single, double, or triple? Triple covalent. Triple covalent.
What's the height of this number?
Triple covalent bond.
Alright.
Triple covalent bond. triple covalent bond. Triple covalent bond. Please, please, by God's grace, we shall continue from here in next class. Please go and read this thing, so that when we move, chemical bonding is chemistry. Without the knowledge of chemical bonding, it's a thing that they should use the whole SSR to teach you people. Chemical bonding. When to understand chemistry, chemical bonding is chemistry. At this moment, and please tell your friends to tell your friend to tell your friend, neotisa, we are here to give you the text, to make you study your chemical, your nursing, medicine and surgery, pharmacy, dentistry, anatomy, physiology, physiotherapy, radiography, pharmacology, everything you want to study, engineering. We are here to make you study that. Please tell your friend to tell your friend about neotisa. Join neotisa. Don't miss. At this moment, let us call it a day. I see you when you see me. I remain myself, Chama. God be with you.